So here we're asked to find the water's phase and sketch its state on a PV and TV plot when the water is at a pressure of 10 bar absolute and a temperature of 179.88 degrees Celsius. So rather than work this out on a blank piece of paper, since I'm referring to some tables, I just figured I'd copy over the written solutions I already have. Now, to figure out what phase we're in and what the other properties are for the water at these conditions, what I did is I went to the saturated water pressure table, which is shown here on the screen. So this is the saturated liquid vapor mixture table for water. And specifically, I did the one that was organized according to pressure because we're given a nice pressure of 10 bar. It's a nice even pressure. So using the one that's organized based on pressure is probably easiest. And then I just go down to 10 bars of pressure. These are all absolute pressures. And notice that the corresponding saturation temperature is 179.88, which is the temperature that I'm given. So that means that we're in a saturated liquid vapor mixture state. That's the phase we're in. Now, if we draw this on a PV diagram, let's do that one right over here. Here's a PV diagram. So I have pressure on this axis, specific volume on that axis. Here's our vapor dome, just sketched in. Here's the pressure of 10 bar, just drawing it over this way. And the corresponding saturation isotherm is this line right here. So the isotherms go from the upper left to the bottom right. The way I remember that is when I write isotherm, let's first of all spell it properly. In the M here, the M goes down at the very end, so that's what makes me think about this. This part for the M where I go down just makes me think of this. It's just my little mnemonic for trying to remember what an isotherm looks like. An isobar, let me put the isobar on the other side. For an isobar, I always remember that R goes up at the end, so that gives me this isobar going from bottom left to upper right. Again, just a little mnemonic to remember that. So anyway, I have my vapor dome, my isotherm that's corresponding to the saturation temperature at 10 bars. Now, I'm going to be somewhere in the saturated liquid vapor mixture state, somewhere underneath the vapor dome here. And I don't know exactly where because I'm not given enough information, but I do know that my specific volume will be somewhere between the saturated liquid specific volume of this value, which is given right here, and the saturated vapor specific volume, which is given right there. So I know I'm somewhere between those. I just don't know where without additional information. Now, as far as what the other properties might be, let's say specific internal energy. I know the specific internal energy will be somewhere between its saturated liquid, its specific internal energy value of 761.39, and the saturated vapor specific internal energy, the 2582.7. I know its value is somewhere in between there, but I don't quite know where. So anyway, I'm somewhere in here in my, as far as somewhere in there is where my state is. Now on the TV diagram shown over here on the left, again, I draw the vapor dome. I draw my isobar corresponding to the saturation isobar at a temperature of 179.88. Remember, that's the temperature that we're given right up here. So here's the 10 bar isobar corresponding to that saturation temperature. And again, I know my specific volume is somewhere in this region here. I just don't know where without some additional information. That additional information, by the way, would be something like I could be given what the specific volume is. I could be given what's known as the quality. That's a topic we haven't covered yet. I could be given what the exact internal energy is, and then from there I could calculate the quality and the specific volume. But basically I need some additional information to figure out where I am in this region. But I do know that I'm in a saturated liquid vapor mixture phase here. Okay, we'll end it there.